I'm recording now. Okay, I'm recording now, so you don't want to keep talking over me and make it look like you're not good listeners. All right. So, to answer those same questions again that were asked while the recorder wasn't quite recording yet. Test is Friday. 2 days on the study guide because we have shortened class periods again this week. Are we out of rulers?
Yeah.
How many more do you need?
I think like 5.
Oh, 5. Okay, here's 3. Four.
I thought I had one in my backpack.
5.
She needs one too.
6. Here you go. Here's a paper.
What happened?
And Jean needs one too, Makadas. Did you grab one for yourself, man?
No, I forgot.
Okay.
Why?
No.
What?
Okay. All right, now stop being creepy, everyone. Remind me tomorrow.
Yeah.
Remind me tomorrow to show you a few of the things on the graphing calculator for the test, the MCA test too, by the way. Okay. We're gonna do inequalities, systems of inequalities. So what you're gonna do is you'll graph one line, and you'll shade, and then you'll graph another line, and you'll shade, like that, and then you'll look to see where the solutions are, like that. Yeah.
Is the solution like where they intersect or like where they shade?
Where the shading overlaps.
So how would you like?
You aren't going to write the solution like this. You're not going to write something like 2,8 when you have the solution. The solution will just be the space where the overlap is. But you won't write like a place where they cross anymore. Not like that.
So you just leave it like that?
Yep. But we are going to check some solutions. So for example, I got to find my notes here. Here we go. You can check solutions in your homework today.
You have homework?
No, in your homework tomorrow. You're going to see something like this. Copy this inequality down. So this is a system because there's 2 of them. And systems can be more than 2, but we usually stick with 2. And then here's the point that you're going to check. Now, in your homework, when you do it, this point will be given to you. You're not going to have to find that anywhere. It's going to be a point that's decided. So what you'll do is you can sharpen while I'm talking. I don't mind. You're going to take that point, like 2 and 12, and plug them in for X and Y. And then you're going to do the math and see if it works or not. And by works, I mean like at the end, does it give you a true or a false statement? So you follow the order of operations. You multiply before you add. Good grief. So you get 12 is greater than 4 plus 4. And 12 is greater than 8, which is true. So that would mean that it is a solution. So what that could be telling you is that, and you're not sure yet, it could be telling you that it's here in the overlapped region, or it could just be telling you that it's here in the shaded region of just one of them. You don't know. You don't know yet if it's just in the one shaded or in the both shaded. You guys got to quit doinking around over there, okay? So now you have to check and plug it in for the other one to see. Not knowing what the 2 inequalities look like, you still need to know. So then you say 12 is less than 6 plus 7. Always make sure you get it down to one number on each side. 12 is less than 13. So that is true. That tells you then that it's in the shaded region of both. If it's true for both, then it's in the shaded region of both. That lets you know that it wasn't just up in here for one of them. It was in here for both of them. That lets you know that it is a solution to the system. That lets you know that it's a solution to the system, not just one inequality. If you were to do this and the first one were to come out as false, then you were done. You don't need to plug it into the second one at all. There's no point in that. Do you have any questions about checking a point to see if that point is a solution? Yep.
So that's all you have to do for it?
Yep, that's all you have to do to check a point. We're going to do graphing now. Yep.
Do you have to like write an answer being like it's true for both?
Now, at this point, I would just say, yes, it is a solution. I would write that. I don't necessarily write this underneath each one, though. I leave that part out. I show this work right here. And then write yes or no on the side. Okay? All right. Draw a line in your notes, and we'll do some graphing practice. So I started correcting the 6-1, 6-5 quizzes, and I picked out a couple problems here that'll give us some practice for graphing that you guys kind of looked like you might need. So if you have y is less than 2x minus 3, and 2x plus y is greater than 2. We have a slope-intercept graph and a standard form graph. The notes that you see up on the whiteboard right now are going to be the same notes I'll keep up on the board when you take the test on Friday. I might have to rewrite them or I'll cover them up. I don't know because I can't be up there when the MCA test is going on, but I'll figure that out later. Maybe I'll just rewrite them. But I want to practice graphing each one of these so that we can just talk about how each one's a little bit different again. I must have left my ruler in Pilney's room. All right. Oh, there it is. All right, make your grid. Oops. All right. Now, when you're graphing one like this one, where y is all alone, y is isolated like this, then you plot this first on the y-axis. This is called a y-intercept. And you plot that on the y-axis. 1, 2, 3. Plot that at -3, because you treat that like a negative. Then this is your slope, the number in front of x. So when y is alone, this is a slope. If it's not written like a fraction, you write it like a fraction. You put it over 1. If it's already written like 1 over 4x, then leave it like that. But if it's not, put it over 1. That tells me to go up to the right 1. It's a rise over run. Yes?
Okay.
Okay.
Sorry, why is the -3 instead of positive?
Oh, because it had a -3 sitting here. That was a minus sign.
Okay.
So I did like a plus and negative with it. So with your slopes, if they're positive, it's like up and then over. The bottom number is always considered to be a positive. If there's a minus sign in front, you always give it to the numerator. So it's up 2 over 1, up 2 over 1, up 2 over 1. And that symbol right there is telling me solid or dashed?
Dash.
Dash. If it had this sign underneath it, that line, that tells you to make it solid. So make a dashed line right now. Like that. And then when y is isolated like this, you don't need to pick a point to decide your shading. You can just look and decide how to shade. So it's telling you that y is less. So you will shade the lesser part of y. So you'll do your shading like this. And some people like to use colored pencils so that they have two different shading things going on. And I have a bunch over there, so when you do your homework tomorrow, you can do that if you want. You can also use like different lightness, super light, and then a little bit darker. You can do whatever kind of works for you. I always feel like when I use colored pencil, I'm going to mess up, and then I'm going to be trying to erase colored pencil, and it's a hot mess. But here I am using marker, and inevitably I'll make a mistake. All right. Here I've got a problem that is not in slope intercept. I don't have y isolated. I have x and y on the same side together. And that's my indicator that I want to use 0, blank, blank, 0. That's called finding the x and y intercepts. So I plug in 0 for x, 2 times 0 plus y. Oh, dang it. See, using pen. Now, I switch this symbol to an equal sign when I do this. It's not a big deal if you don't. I do that because I'm just plotting a point, so I don't really feel like it's got shading, so I just make it an equal sign. So I get rid of that, and it's telling me that y is just 2. So when x is 0, y is just 2. Then I plug in 0 for y and say 2x plus 0 equals 2. Again, turning that into an equal sign because it's just a point. It doesn't really have shading. When you zero out y and you divide by 2 on both sides, when you zero out y, x would equal 1. When you zero out y, x would equal 1. Now, these two are two separate points. They're two individual points. You don't like put them together or anything. This is not a rise and a run. Rise and run looks like this. Up 2 and over 1, it's a fraction. Rise and run is never a point. These are two individual points. So when you plot them, it's on y, you plot a 2. So 1, 2. On x, you plot a 1 over 1. Like that. Does that make sense, you guys? Because this is the one I'm like seeing people mix these two up. I'm seeing people want to plot this style on this equation. I'm seeing people want to do those opposite sometimes. So you need to really practice how to graph these two. Solid or dashed line?
Solid. Dash.
Remember, if it's got this thing underneath it, it's solid. Without it, it's dashed. So make yourself a dashed line here. Heck yeah. Now, I'm not really worried about the fact that I can't name the exact place where these two cross. I don't really care about that. And the reason why I don't really care about that is because I don't have to name that place really here. I'm looking for the place where the graphing overlaps, the shading overlaps. I'm less concerned about where the two lines cross. Now, when I go to shade, you might want to write yourself a note here. I'm going to write shade. And when you decide which way to shade, you plug in a point. Do you guys remember the point I typically use? 0, 0. You can use 1, 2, 2, 2, 2, 3. If you have like a favorite number, do your thing. I use 0, 0 because the math is easy. So I pick a favorite point. And then I check, and I leave this symbol in this time because I need to know, should I shade that way? So I'm checking, is 0 really bigger than 2?
No.
It's not. So when I'm doing my shading, if 0 is not part of the solution, I don't want to shade, this is my purple line here, I don't want to shade where 0 is. So when I think about that, it's going to look kind of like this on that purple line. I don't want to shade where 0 is. I want to shade the other side of that line. So I'm going to set this here, and I'm going to start shading not where 0 is, but the other side. And the solutions then are where the two graphs, where their shading will overlap each other. Their shading crisscrosses with each other, and that's where that set of solutions is. This is where a point like in that last problem we did, this is where a point like that 212 would be sitting. This is where a point that would fit both problems would sit. If I picked a problem from the pink section, it would fit only this. And if I picked a problem from the yellow section, it would fit only this. But if I pick one from the overlap, it fits both. How are we doing so far?
Good.
Is it making sense though? Yeah? No? Okay. All right, let's do a set of parallel. I think we can make this fit right here. Try y is less than 2x plus 4. And 2x minus 1 is less than or equal to 4. We're going to graph these two right here. This one's in slope intercept. So when you start it, you plot that 0, 4. You plot that on the y-axis. That's your starting point. I feel like I'm not loving the earth today. I've used a lot of Post-its. So you plot 0, 4. 1, 2, 3, 4. That's your slope. When y is isolated, you're working with a slope. You turn your slope into a fraction if it isn't one. It's a rise and a run. A rise and a run. If it's a negative number, it would fall. It would go that direction. So it's going to go up 2 and over 1. You might have to reverse that so it can fit on your graph. Should I do a solid or a dash line? Okay. Y is isolated. Is that telling you to shade above or shade below? It's saying that y is less. That would mean we shade the lesser part. So we want to shade everything that is less on y. See how it's like all the lower stuff there. So we're going to shade all the lower stuff on y. Which, because the line is so steep, it's almost like you're shading all the right, not the less. The steeper a line gets, the more it seems like it's left and right, not below and above. But I left the higher part of y unshaded there, you'll see. This is a standard form equation right here. X and y are on the same side together. So we're going to do that 0, blank, blank, 0. So you say 2 times 0 minus y equals 4. That right there is like a -1. So you have to divide by -1 on both sides. And you get y equals -4. Then you fill in 0 for y. And you get 2x minus 0 equals 4. And you divide by 2. And you get x equals 2. So you go over here and put in a 2. And then just a reminder, those are two separate points. They're not a slope. It's not a fraction. It's a point. So it's a point at 0, 1, 2, 3, 4. And a point at 2, 0. Solid or dashed? You put your line in. And I've got two parallel lines that normally when you do parallel lines, when you graph them, you think to yourself, well, that should be a no solution, normally. But now when you're doing inequalities, the only way that a parallel lines would be no solution is if the shading goes like this. If the shading on parallel lines goes away from each other, then it's a no solution. If the shading, however, overlaps anywhere, then it has a solution. So you have to be kind of careful on these. So this one right here, if you take this equation, inequality I mean, and plug in a point, what point do I like to use?
0.
So use 0, 0 for that and say 2 times 0 minus 0 and see if that's really less than 4. Is 0 really less than or equal to 4? Yeah. So for that line, shade in the direction of 0. And what you have here is a graph that is 100% completely shaded, the whole entire thing. Nothing is left unshaded about it. The whole thing is shaded. All of it is shaded. However, only this section right here represents solutions. Like that solid line all the way up to right until you just about touch that dotted line. Those are all solutions in there. Because remember, to be a solution, it has to fit both inequalities, not just one, even though the whole thing is shaded. So now I'm going to have you guys try a few just for practice. I'm going to put some up on the board. They're in Google Classroom too if you have a tough time seeing the board. So I'm going to have you try just a couple of these. Sure. If that makes you feel happy inside. All right. Why can't I present that? A window?
What?
Full budget.
All right, there you go. I would probably,
I think it's all. We already do the.
we did 11. I would do 14. I would do 17.
That would be 27.
And we did 7, so I would not do that one. Whoops, don't do that.
Make an X model.
I know, but now I can't. I'm like in the rectangle making things. I don't want to make another rectangle. Go back. There we go. Don't do 7. Don't do 11. We did those. Okay. 10's not bad. I'd do 10. All right. Hop on it. Do some math. Math it up, y'all. I'm going to walk around.
That's good.
Beautiful. Wow.
Monies are affecting each day.
What are you gonna do?
No way! It's 10 hours! Palms, balls, and frogs! Sorry.